Hello. So in the last video of this series, we had covered the basics of age problems, simple ones with ratios and time shifts like 10 years ago, 10 years after, problems like that. We also covered some intermediate level problems like a ratio change over time, such as where we solved a problem where there were two ratios of a man, and even after time shift there were only ratios, there were no numeric numbers, and we calculated their percentage based on that only, right? So here in this video we're going to discuss and solve some complex, tricky and a bit difficult problems, or in natural medium to difficult level problems that might pop up in even in less competitive exams or prelims and something like that. So we will start solving these problems. So the first problem is that a man is 4 times as old as his son. After 5 years, he will be 3 times as old as his son. After another 5 years, what will be the ratio of their ages? So the problem type of this is multiple people and future prediction. So what we will do, a man is 4 times as old as his son. Let the variables be m and s, right? And s. So m equals to, the man is 4 times old as his son, m equals to 4s. After 5 years, he will be 3 times old as his son. So after 5 years, m plus 5 equals to 3 times s plus 5. If you don't know where the 5 and all these are coming, I suggest you watch the first video where I explain in detail where the time shifts and how these are working. So if we just solve it, m plus 5 equals to 3s plus 15. So m equals to 3s plus 10. So 4s equals to, from 1 and 2, from 1 and 2, 4s equals to 3s plus 10, 4s minus 3s equals to 10, s equals to 10. Now they said that okay, after 5 years, so you need to understand this part that they said in present a man is 4 times his son, and in future after 5 years the man would be 3 times as old as his son, right? And after that, after another 5 years, after, we are already here at 5 years, we are already 5 years in future, and they are saying after another 5 years, that means we are going 10 years in future. As we have the value of s, we can just do m, the ratio of their age, m plus 10 and s plus 10, right? M plus 10 is, what is the value of n? So m equals to 4s, m equals to 4 times 10 equals, m equals to 40, then m equals to 50, and s equals to 20, s equals to 20, right? So what would be their ratio? So it would be m by s ratio, m by s equals to 50 by 20, m 50 s 20, or we can write mx to s equals to 50x to 20. So the answer is 50x to 20, right? Now the next question, it's a 3% age comparison problem. So up until now, all the problems of age-based problems we have solved in the reasoning or aptitude or logical category, all of them were 2%, mother and daughter. Father is 10 years older than, father is twice as old as his son. All father, mother, daughter, like things like 2% age comparisons where we solve the equation. But this is the first problem where we will be solving 3% age comparison. So let's read the question first. It's the sum of ages of a father, son and daughter. The sum of ages of a father, mother and son is 93 years old. Let father is f, mother is m, and son is s. I wrote capital letter, but we'll just assume it's small letter for our convenience, right? May not need to write all the father's age, let the father is young, because we're in an exam, you just need the answer. You don't need to write entire variable things, right? So the total sum of all their ages is 93. So we can write like f plus m plus s equals to 93, equation number 1. Now what further they have given, they said the father is twice as old as his son, so we can write f equals to 2s, equation number 2. And the mother is 12 years younger than the father, so we can, father is 2s, so we can write m is 2s minus 12. Because they said the mother is, we could also write it is we could also write f minus 12, but it is useless because we know the value of f, so we'll directly put the value of f, which comes to 2s minus 12. Now they said that find their ages. Can we find their ages? We definitely can. What if we just combine, like put equation 2 and 3 in equation 1? Simple. So the value of f is 2s plus 2s minus 12 plus s equals to 93. We become 4s as 5s equals to 93 plus 12, that comes to 105. So s comes to 21. So find their ages. So the father's age is 2s, right? So father age is 21 times 2, then it comes to 42. Son's age is 21, mother's age is 42 minus 12, right? 30. So as simple was that. So here's the answer for the question number 2. Now what we are going to do, we are going to solve some multiple age problems, right? So the first question is, the age of 3 friends are in ratio of 2:3:5, and if the youngest is 14 years old, find the other age of 2 years, other two. Okay. The age of the 3 friends are 2:3, 2:3:5. So the ratio is 2:3:5. We can the ratio we can write as 2x plus 3x plus 5x. Now we don't have a total yet. So they are saying that if the youngest is 14 years old, find the age of the other. It's very simple, but they are saying the youngest would be obviously the ratio that is least in this given number, 2:3:5. So that is 2x, right? So they are saying 2x will be 14, so x equals to 7. Then the other's age is 3 times 7 and 5 times 7, so it's 21 and it's 35, right? So here the question 3, it is very simple. So we were just asked to find the age of others, but we already were given the age of the youngest, which is youngest friend, right? So the youngest friend would be obviously the 2x2 in the 2x1. So here's the solution for the question number 3, and we'll now go to the question number 4, right? So let me just write it. Find the ages of other two. Other friend ages is 21 years and 35 years. 35 years. Now a grandfather's age is the sum of his 2 grandchildren's. Okay, one grandson is 2 years older than the other. If the grandfather is 56 years old, find the age of the grandsons. It's also very simple if you focus on the problem. So one grandson is 2 years old older than the other. So let's assume that the first grandson is x. So the other grandson would be x plus 2. Obviously, because they are saying that one grandson is 2 years older than the other. So it's 2 years older than the other. And they are also saying that if the grandfather is 56 years old, and they said the grandfather's age is the sum of ages of two grandsons. So they are saying x plus 2 equals to the age of grandfather, who is 56 year old. So it's 56, then 2x equals to 54, and x equals to 54 by 2, which comes to 27, right? So the first grandson is 27 and 29, because x plus 2 equals to 27 plus 2. Now they are saying that now we come to an advanced level problem. They are saying A says to B, I am 3 times as old as you were when I was as old as you were now. If A is currently 60 years old, find B's current age. Now if you watch the last video, we solved this through a methodical problem, a methodical procedure, as well as a trick or a universal pattern. In the universal pattern, I also showed that if this is it was 3 times as old as you were, like if these things are mentioned, we can use the universal pattern ratio or formula of 3x to 2 if it is 3 times. So you can say that ax to b equals to 3x to 2. It's from the formula or the universal pattern. So a by b is 3 by 2. We can write like that. We have the value of A is currently for 60 years old. So 60 by B is 3 by 2. So 3B equals to 120. Then B equals to 40. Correct? So find the B's current age. So B is 40 years old. Now coming to the next problem, they are saying the product of the ages of two sisters is 96. The elder sister is 4 years older than the younger. Find their ages. Now here the product. This means the multiplied value of their ages. That means if one sister is 2 years old and another sister is 4 years old, their product will be 2 into 4 equals to 8. So they are saying that the product of the two ages of two sisters is 96, right? So how will you find that? So first let's assume that the sister is x and other sister is x. The elder sister is 4 years older than the younger. So the elder sister is 4 years younger than the younger, right? So the big sister is 4 years older than the younger sister. That means if the younger sister is x years, older sister is x plus 4 years. It's obvious. Now they're saying the product. That means x plus 4 into x equals to 96. So x square plus 4x equals to 96. I can write it more clearly like that, x plus 4, because the product will be multiplied version of them, that is 96. So x plus 4x equals to 96. So x square plus 4x minus 96 equals to 0. We just took the 96 to the left side, and now it's a quadratic equation. We can write like now as per the quadratic equation, we need to have value where the summation is 4 but the multiplication is 96. Instantly it comes to my mind 8 and 12. So if you do 12 into 8, 16, 1, 8, 96. So we can write like x square plus 12x plus 12x minus 8x minus 96 equals to 0. Because there is a plus 12 and minus 8, the total is coming to plus 4 only, plus 4x only. So we are not changing this. So my plus 12x minus 8x is to plus 4x only. But if you multiply them, that comes 96. So we take common x plus 12. We take common minus 8, comes x plus 12. The minus, for this minus it's coming plus, and for this minus it's coming plus, x plus 12. We'll take x plus 12 as common and x minus 8 as common, equals to 0. Now the age will be either x equals to minus 12 or x equals to 8. Now notice that age, it's a general common sense that age cannot be a negative integer, right? Age cannot be a negative. So we will take the value of x equals to 8. So if we take x equals to 8, okay, then the other sister is going to be the younger sister. Younger sister is 8 and older is 12, and their multiplied sum is 96, as we just did, right? So their product is 96. So their age is 8 and 12. Now coming to the next question, that the difference between the ages of two cousins is 10 years old. It is a bit different because up until now we were doing the summation, right? The sum of two sisters, the sum of mother and son, the mother and daughter, or father and son, things like that. But it's the first problem where we are doing the difference. That means it will be negative. So let's do that. The difference between the ages of two cousins is 10 years old. Let's let a cousin is x and y. So we can write x minus y equals to 10. If 15 years ago the elder was twice as old as the younger, find their present age. Elder was twice elder. Let's assume the elder is y. So 15 years ago, we will write like x minus 15 equals to, let's assume the elder is x, right? It would be easy for us for calculation. X minus 15 equals to, so if 15 years ago the elder was twice as old as the younger, so if 15 years ago x minus 15, it would be the younger and it would be the old elder sister, right? So x minus 15 and y minus 15, we subtracted 15 to demonstrate 15 years ago scenario. Now they are saying twice as old, so it will be twice, right? So it will come to x minus 15 equals to 2y minus 30. So x equals to 2y minus 15, because it would go to this side, it would become plus. So we have x minus y equals to 10, x equals to 10 plus y, right? Because it's minus, if it goes to this side, it would become plus. So 10 plus y equals to 2y minus 15. It would come to y minus 2y equals to minus 15 minus 10. It would come to minus y equals to minus 25. Y equals to 25. Hence x minus y equals to 10. Then x equals to 10 plus 25. Okay, so the older sister, I think I might have mischaracterized. The older would be x, because we cannot do, if the younger if we subtract younger from the older, it could come, the age would come to negative. But they are saying that the difference is 10 years, so it's not a negative number. So the older is x, right? So the older comes to 35 years old. I might have mischaracterized stating the y is older, I think, but the older is x, and x minus y equals to 10. So as per that, the value of older sister is 35 and the value of younger sister is 25, because we are subtracting older sister from younger sister, which comes to the difference of 10 years, right? We will always subtract from the value higher than, because the difference between the two cousins are 10 years, we will subtract from the older sister from the younger sister, otherwise the difference would come to negative, right? So that's why that way. Now next we'll solve a complex problem. It is just a single complex problem in this video, that a teacher's age is square of student's age. If 3 years ago the teacher was 11 times as old as the student, find their present age. It is very unlikely that you will find that kind of complex problem, because it's very hard to draft that kind of complex problem, because otherwise the answers generally comes to invalid. But I've checked the question, it's a correct question only. Okay, so through this problem you will understand that even if such a type of complex problems comes, how to solve these kinds of problems. So teacher's age is square of student's age. Let the student age be x, then the teacher's age would be x square, right? Now if 3 years ago, so x minus 3, the teacher was 11 times as old as the student, 11 times. So we'll do, it would be x square equals to 11 times x minus 3, because they're saying if 3 years ago teacher was, the teacher is x square only. So 3 years ago, okay, it would be x square minus, okay, 3 years ago x square minus 3 equals to 11 times x minus 3. 3 years ago we subtracted 3 from both sides, x minus 3 from student, x square minus 3 from the teacher. The teacher was 11 times as old as the student, so we multiplied by 11, find their present age. Let's just solve it and let's see, right? Because we have no other correlation between them, that their sum, their product, like this question, their product, their sum or their difference, we have nothing like that. We just have a single relation, that if 3 years ago the teacher was 11 years, the teacher was 11 times as old as the student, find their ages. But we can also write x square x equal to x equal to x square, right? So let's do x square minus 3 equals to 11x minus 33. X square equals to 11x plus minus 30. Go to plus. Now x square minus 11x plus 30 equals to 0. It's a quadratic formula. We can write like 11x 30. The product need to be the sum need to be 11, and the multiplied has to be 30. So how do we do that? We can do it like x square minus we will divide 30. We can do by 2, 15, and 15 we can get by 3, 5. Okay, so 2 times 3 is 6 plus 5, 6 times 5. We can do like that. So if you see, I divided 2 with 30, we got 15, and then I divided the 15 with 3, I got 5. So we can do like 2 times 3 this, and 5. So it's 6 plus 5, and if we multiply 6 times 5, it's 30 only. So we can do 6x minus 5x plus 30 equals to 0. X square, we will take x is common, x minus 6 minus 5, x minus 6 equals to 0. So it comes to x minus 6 or x minus 5 equals to 0. Right. So we either the value of x would be 6 or x would be 5. Everything is correct. Now if x equals to 5, if x equals to 5, the teacher's age would be x square. That means 5 square equals to 25, right? But 3 years ago teacher was 11 times, right? So if the student was 5 years student, right? Student's age is now 5 years. 3 years ago student would be 5 minus 3 equals to 2 years old. So if we multiply 2 by 11, it comes to 22. That matches. But if x equals to 6, then x square equals to 36, and 3 years ago it would be 3 years ago 6 minus 3 equals to 3 into 11, it comes to 33. Okay, so both answers satisfy. So there are two possible solutions for this problem, that it can be 5 and it can be 6 as well. The answer can be both of them. So lastly, just understand this point. If it would have been 7 or 8 or any other thing, we could have done this to verify that what is the correct answer. How did we do that? They gave the relation that if 3 years ago the teacher was 11 times as old as the student, so if we found the age of the present student as 5, so it subtracted 3 from 5, which is 3. So 3 years ago the 2. So 3 years ago the age of the student was 2. So if we multiply by 11, because they said 11 times, what is the age of the student, age of the teacher? 22 years old. So even if we do square, then the age of teacher is 25. We subtract by 3, it comes to 22 only. So it's correct. So in same process we did with x plus 6, and it also follows, right? So if hypothetically x was 7, then it's 49, right? 7 square equals to 49, and if we subtract 7 from 3, we come 4 into 11 is 44. But 49 minus 4 is 45. So if the value of x would have been 7, it would have been not possible. Got it? So that is one complex problem that we did. In the next video, we'll do 5 more bit complex and tricky problems, right? So thank you.